Hey, it's Mr. Alexander, and today I'm here to talk to you about solving absolute value equations for x. So let's jump right into it. If you have something that says the absolute value of x equals 12 and you want to get the x by itself, ask yourself a question. Is there anything on the outside of these bars here? If the answer is no, then you can break this up into two equations. The two equations you can break it up into are x equals 12 and x equals negative 12. So most of the time these absolute value equations will have two solutions. In this case it's 12 and negative 12, but that's not always the case. For instance, right here, negative absolute value of x equals 4/3. Ask yourself the question, is there anything on the outside of those bars? The answer is yes, that negative. We need to get rid of it. We need to move it to the other side. So to do that, we're going to multiply negative 1 on both sides to cancel out those negatives. So that negative cancels that negative. That's going to give us the absolute value of x equals negative 4/3. And in this case, we don't need to break it into two equations, because I'm just looking at this equation and I know that there's nothing I can plug into this absolute value equation to make it spit out a negative number. That's the whole point of absolute value. It takes negatives, makes it positive. It takes positives and keeps them positive. There's no way to plug any number in here and make it spit out with a negative number. So this is no solution. Anytime you've got the absolute value bars by themselves, there's nothing on the outside of them, and the other side of the equation is a negative, that's going to be no solution every single time. All right, here's another equation. Ask yourself the same set of questions. Is there anything on the outside of the bars? No? We can break it into two equations. We've got 2 minus 2/3 2x/3 equals 1, and 2 minus 2x/3 equals negative 1. Process is the same every single time. One side is 1, the other equation is negative. Excuse me. So we need to solve both these equations to get the x by itself. I'm looking at that 2 first. I'm going to subtract 2 from both sides, so minus 2 minus 2. I'm going to have negative 2x/3 equals, that's negative 1. Now I'm going to get rid of this negative and this 3. The opposite of divide by 3 is multiply by 3. And to undo that negative, I'm going to go ahead and multiply by negative 3. Whatever I do on one side, I have to do on the other side. So this negative is going to cancel out with that negative. This 3 is going to cancel out that 3, leaving me with 2x equals positive 3. So negative 1 times negative 3 is positive 3. Now, of course, to get the x by itself, you divide by 2 on both sides, and you get x equals 3/2, or 1/2 if you prefer. So the first solution is x equals 1.5. Now we need to get the other solution here by doing the same process. I'm going to subtract by 2, subtract by 2. I've got negative 2x/3 equals negative 3. All right, again, I'm going to multiply both sides by negative 3 for the same reason as before. That negative cancels that negative. That 3 cancels out with that 3. So I've got 2x equals, now it's going to be positive 9. And to get the x by itself, you divide by 2 to get x equals 9/2. And so the two solutions here are x equals 3/2 and x equals 9/2. And you should always plug those solutions back into the original equation to make sure that they work. That's how you double check your work. Plug it back in and make sure it spits out 1 when you plug it in. These both are correct. All right, let's keep going. 2 times the absolute value of 7x minus 1 equals 5. Is there anything on the outside of those bars? Yes. There's that 2 right there. So I need to get rid of it before I can split into two equations. So this is 2 times all this stuff. So what I need to do is divide both sides by 2. That'll give me the absolute value of 7x minus 1 equals, well, 5 divided by 2 is 5/2, or 2.5 if you prefer. I'm going to go ahead and write it as 2.5. And at this point, there's nothing left on the outside of those bars, so I can go ahead and split it into two equations. Those two equations, 7x minus 1 equals 2.5, and the negative one, 7x minus 1 equals negative 2.5. And from here, it's pretty simple algebra. I'm going to add 1 to both sides to get 7x equals 3.5. And then I'm going to divide by 7 to get x equals, well, 3.5 is simply half of 7, so this is going to reduce to 1/2. And you can check that in your calculator. So that's one of the two solutions. And the other one, if you add 1, you're going to have 7x equals, so negative 2.5 plus 1 is negative 1.5. And then we're going to have to divide that by 7. Divide by 7, divide by 7. So that's going to be x equals, I'm going to go ahead and convert that back to a fraction for a moment. So that's negative 3/2. And that's all going to be divided by 7. And there's two ways you can look at this. You could either do it in your calculator, which is probably the easier of the two ways, or whenever you have a fraction divided by another fraction, in this case the other fraction is 7/1, you flip and multiply. So this would be negative 3/2 times 1/7. So 2 times 7 is 14. So this is going to reduce to x equals negative 3/14 is the other solution here. Okay? So the hardest part of that was dealing with fractions, but that's why we have calculators. Don't make it too complicated if you don't want to. You should know how to do the fractions, but don't make that the reason that you get these problems wrong. Okay, here's a fancy one. We've got 6x minus 2 divided by 3, the absolute value of that, equals 4x plus 1 divided by 5, the absolute. So what we need to do, the process is exactly the same. What we're going to do is ask ourselves, is there anything on the outside of the bars here? Is there anything I can do to simplify this expression? And the answer is no. There's nothing going on here that I can do. So I'm going to break it into two equations. I've got 6x minus 2 over 3 equals 4x plus 1 over 5. That's one of the two. And the other one is 6x minus 2 over 3 equals, here's the positive, make the other one the negative. 4x plus 1 over 5 with a negative in there. So I'm just going to solve each of these individually. The easiest way to do these is simply cross multiplication. So multiplying these things together and multiplying these things together. So that'd be 5 times 6x minus 2 equals 3 times 4x plus 1. Zoom in on that so you can see it. And from this point, we're back to Algebra 1, so we're just going to simplify. 5 times 6 is 30x. 5 times negative 2 is negative 10. 3 times 4 is 12x. 3 times 1 is plus 3. Let's solve for x. Minus 12x, minus 12x, plus 10, plus 10. I've got, what is that? 18x equals 13? That sounds right. And so to solve, we're just going to divide both sides by 18, so x equals 13 over 18. No need to simplify that into an ugly number. That's one of the two solutions. Now let's jump over here and do the other one. Same process, but now I've got a negative in front, so I simply need to distribute that negative either to the top or to the bottom, certainly not to both. I'm going to go ahead and choose to distribute it to the bottom. So I'm going to get rid of these parentheses. I'm just going to put that negative on the bottom there. If I distribute it to the top, then it'd make it negative 4x minus 1. This just feels simpler to me because I'm going to cross multiply. and I'm going to get 3 times 4x plus 1, same as before, equals negative 5 times 6x minus 2. Okay, same process. Let's go ahead and distribute. 12x plus 3 equals negative 30x plus 10 when you distribute that negative 5. So let's add 30x to both sides. And let's subtract 3 from both sides. And that's going to give me 30 plus 12 is 42x equals 7. Alright, so divide by 42 on both sides to get x equals 7 over 42. Or if you are a fraction connoisseur, you know that reduces to 1 over 6. Alright, I'm at 11 minutes, but I'm going to go ahead and do 2 more. There's a couple other things I want to talk about here. This is definitely the hardest kind of problem right here. So if you can handle this, you're probably in good shape. Let's jump over to this right here. We've got negative absolute value of negative x plus 4 minus 6 equals negative 2. Is there anything on the outside of those bars? There sure is. But you might be noticing there's a negative 2 over here. So you might be inclined to say there's no solution. But before we can make that determination, we need to get the bars by themselves. We can only say that it's no solution if the bars are by themselves, and then there's a negative over there. So let's go ahead and add the 6. To get negative 5, absolute value of negative x plus 4 equals positive 4. See, it's turning positive. And we need to get rid of that negative 5, so let's divide both sides by negative 5. Those cancel out. I'm left with the absolute value of negative x plus 4 equals negative 4 over 5. Now the bars are by themselves, and there's still a negative over there. What that means is, yes, this is definitely no solution. So make the determination after you've gotten these bars by themselves. So there's nothing on either side of them. And then if it's negative, you can say, yeah, that's no solution. Okay, last one. 2 plus the absolute value of x minus 4 divided by 5 equals 9. Bars are definitely not by themselves, so I'm going to subtract 2. Absolute value of x minus 4 divided by 5 equals 7. I want to get rid of that 5, so I'm going to multiply by 5 on both sides. Absolute value of x minus 4 equals 35. Bars are by themselves, so I can break this into 2 equations. X minus 4 equals 35, and x minus 4 equals negative 35. Solve them both for x. Plus 4, plus 4, plus 4, plus 4. X equals 39 and negative 31. All right. That's all I've got for you. Hopefully this got you pointed in the right direction for solving absolute values. Thank you for watching. We'll see you in class.